So today we will start our topic. So I hope in our last class we have seen some basics. Okay, once again I will tell you, firefighting mostly like the system, like in firefighting, the system is already defined. Okay, if you check any standard book, you will see that all the systems are given. What we need to do certain designing calculations here, and what we need to follow, that is the most important thing actually here. So let me just write 1 minute. I will just write down some systems here, the standard the standard systems which are given in firefighting. First you will see that there is one system, so which is like called as wet sprinkler system, or normally you can call it as the sprinkler system. Okay, so this is the most common system in firefighting. Now, what is sprinkler system, what is the meaning of sprinkler, and why it is important, everything going to learn here. Just a minute. Okay. So these are the things what we are going to learn here. In the same way, there is one more system called as dry system. Okay, either wet or dry system. So the difference between wet or dry system is that in the wet system, the line is always charged with water. In the dry system, the line is not charged with water. This is the another thing we will discuss this. The second type of system, okay, one is the deluge system. Also, there is one more system. The meaning is deluge system. Okay, everything we are talking in terms of sprinkler only. Okay, in terms of sprinkler, one is the wet system, one is the dry system, one is the deluge system. Now, what is the difference between wet and deluge system? We will see. Okay, and you will understand. And there is one more system which is called as pre-action system. These are the four common systems of sprinkler system: wet system, wet sprinkler system, dry sprinkler system, deluge sprinkler system, pre-action sprinkler system. But these two systems are adopted for special conditions only. Like special conditions means, for example, like if you have any special rooms, or if you have any high hazardous areas, for those regions or for those places, these two systems are used. But this wet sprinkler system is the common system. Okay, for any system we can adopt this system, because for any space, for any region, we can adopt this wet sprinkler system. Now, everywhere, certain what you can say, there is a certain difference between each and every system, which we are going to cover. Okay, in our session we are going to cover this. There is one more system. Okay, apart from this, there is one more system called as foam system. So foam system means, just instead of water, here what happens, the foam particle will come out of the sprinkler. This is the difference. And there is one more last system, is the mist system, water mist system. So this is also sometimes called as spray system, water spray system, or mist system. So these are some standard systems, okay, which I'm talking in terms of sprinkler only. Okay, wet sprinkler, dry sprinkler, deluge sprinkler, pre-action sprinkler, foam sprinkler, mist sprinkler. There are 6 systems which are followed, and sometimes some systems are followed in terms of combination. Now, whatever the system you take, the common practice is that for each and every system we have to perform hydraulic calculation. Okay, for each and every system there is a hydraulic calculation procedure is given in NFPA. Okay, you will find the hydraulic calculation procedure for foam system, you will find the hydraulic calculation for wet system, even deluge and pre-action system also somewhere the procedure is given. So procedure is already given. What we need to do is we need to do the calculation. Okay, but before going for calculation, first we need to understand which system is suitable for which place. Okay, like that we have to go. So I was just telling you about the sprinkler system, but our class we will start with the very basic things first. Okay, like what is fire, why fire is important, like those things we are going to start first. Okay, so basically, if you see, like previously, I believe that 10 to 15 years back, normally fire system or firefighting system is what you can say restricted up to fire extinguishers only. Like hardly we knew about the sprinkler system, or hardly we knew about the hydrant system, because previously the buildings, whatever the buildings were like designed, so they will be having only fire extinguishers. But over a decade of, okay, over the like decades and over certain years, this firefighting system, like the whole world tries to adopt this system, and nowadays it is very common. Okay, firefighting system is very much common. And why this firefighting system is important, so we have recent so many activities, okay, like recent so many accidents happened actually throughout the world. If you see, there are so many like accidents happened in building. So one of the major reason for those accidents is the improper installation of firefighting system. Okay, like recently in Mumbai, I think 4 to 5 days back, one building like caught fire, but they are telling that like it is a construction fault. So somewhere or the other way, okay, somewhere in any way, we will see that firefighting is also responsible, or I will say that the firefighting system is responsible. Why means because we have to adopt the proper standards whenever we are designing the firefighting system. We have to adopt the proper standards. Okay, so how you are going to adopt the proper standard? By learning these codes, NFP and NBC. If you are designing in India, so you require the NBC codes. Otherwise, NFPA codes is given for the universal procedure. So code is already defined. Okay, what we need to do means we need to understand how to like what you can say, do the calculation part, how to do the design part. Already they have given each and every point, like what we have to like select, what we, how much what you can say area we have to select, what is the restricted areas, everything is defined in NFPA. Only what we need to do, we need to organize the things. Okay, so we will start with our basic things. So first we will try to understand what is the basics of fire and all, and what are the types of firefighting systems, like these things we are going to see first. So basically, if you see fire, fire is nothing but it is a process of combustion. So normally what happens whenever there is a fire, okay, whenever there is fire, so what happens normally, it combines with oxygen. The material will react with oxygen. Suppose for example, if you are going in a glass industry and glass catches fire, so how the glass catches fire? Glass will combine with oxygen. Okay, obviously glass will combine with oxygen and it will give out heat and smoke. So this is the very basic definition, and this is also this is only called as combustion. So in combustion, normally what happens, any two objects will combine together and they will give out they will give out the smoke and heat. So here it is written, fire is a process of combustion or burning in which substances combine chemically with oxygen from the air and typically give out heat and smoke. So normally every material or every what you can say element will have the different fire properties. Some materials, some elements are very critical, so they can catch fire if what you can say, if it reacts with oxygen. Okay, if it reacts with very small amount of oxygen also, it will catch fire. And some elements or some chemicals are not that much hazardous. Even if you are giving out like even if much oxygen is like reacting with it, it will not catch fire. So anyhow, whatever the thing, so the definition of fire is says that here what happens, the fuel and oxygen combine together to produce the combustion. Or typically we have heard about the fire triangle. So normally in fire triangle what happens, there will be three process takes place. One is the fuel. So here the meaning of fuel is that it is a substance or the material or the element or the chemical. So when this fuel reacts with oxygen, so what happens, chemical reaction takes place. And when the chemical reaction takes place, normally heat will come out. Because of heat, sometimes smoke and fire will also takes place. So here it is telling the factors which causes fire to occur. It should have the enough oxygen, enough heat, and enough fuel. Okay. Or sometimes fuel is also called as combustible material, the material which can catch fire easily. Okay. Like for example, I think all the materials are combustible only. Most of the material are combustible. If you burn the object, obviously it will burn. There might be some objects or there might be some materials which are not combustible, but most of the objects are combustible only. So this is just one definition of firefighting. Fire. Now, previously, we used to do the classification of fire according to the type of fuel. Okay, like suppose there are types, there are standard classes of fire are given, like class A, class B, class C, class D, class K. Now, just understand one thing. This classification of fire is like it doesn't, what you can say, it has nothing to take with our calculation. Okay, this classification what I am showing you, because our calculation procedures are entirely different. But this classification is only to understand that you are entering into a low hazard area or high hazard area, because sometimes with the shape we can understand that okay, this area is hazardous. You don't have to do any funny thing here. Or sometimes if anyone is like burning anything, just matchstick, and the area is very hazardous, so just because of that one burning matchstick, the whole building can blow out. So that's why this classification is given, but this classification has nothing to do with our calculation. Okay, so here you see the materials like wood, paper, cloth, rubber, plastics. Okay, these are called as class A. So this is a class A classification of fire. I will show you one document also where you will see the this is okay. If the green triangle is given, the green triangle is like it denotes class A fire. Now suppose whenever you are going to any industry or whenever you are going to any place, if you are finding this kind of symbol, so you have to understand that that particular area is like the fire risk area. Everywhere it will not be placed. Okay, it will not be placed everywhere, but only to those places where there is a chance of, like the chances of fire is very high. So it will be placed in this what you can say, a green triangle will be placed here. So this is your class A. The class B is your flammable liquid, like any gasoline, kerosene, paint thinner, or any flammable liquid industries. If you are visiting any or mostly where you are keeping the storage of flammable liquid, so there you will find that the red square will be given. Okay, red square means you have to understand that this is a type of class B fire. In the same way, all the electrical appliances, any electrical appliances or server rooms where there are majority of what you can say electrical equipments are placed, so that will be called as class C type of fire. And class C is nothing but the blue circle. Okay, class D is for your metals. Any metal which can catch fire will be considered as the class D type of okay fire. And class D can be given as this is the star or pentagon, also we can call it as yellow star. And class K is normal letter K. So class K is nothing but our normal like cooking oil or grease, animal fats, vegetable fats, like normally what we are using in day-to-day life. This is the class K. Now this classification is only for our what you can say, just to understand that whether the area you are entering is the high hazard.
Mr. Atif, Mr. Atif, can you hear me? Can you hear me? Yeah, these things it will affect on the calculations. For example, there is an ordinary hazard and there's extraordinary hazards. For example, the sprinkler pipe, for example, 1 inch, for example, it will accommodate, for example, for one sprinkler or sprinklers. But in the extra hazard, you will contain only one sprinkler, for example, something like that. I do believe.
But this will not.
And the GPM of the pump also will be different.
This is just the what you can say symbol. Yeah, this is the symbol representation actually. This will not affect in calculation, because for calculation we have to check the building, not the particular substance or sub particular room. We have to check building. Okay, suppose if you are designing the industrial building, so you will design according to the industrial standard. But this particular classification is according to the particular room. Like suppose in one building you have one flammable liquid storage room. So this particular symbolic representation for particular room only, not for the entire building. So, but it's up to the consumer. If the consumer wants to protect every place of the building.
There is
I cannot hear your voice properly.
There is a classification of the premise. If it is normal hazard or extra hazard, if the system is, if the premise is considered as
your voice is not audible.
Ordinary risk hazard or ordinary risk. Can we use it? Sorry.
I think your voice is not clear. See, classification of hazard is different. Classification of fire is different. Okay. Here we are just talking about the classification of fire. The classification of hazard is different, which is defined in NFPA. So NFPA has defined as 3 hazard, like light hazard, ordinary hazard, or extra hazard. That classification is different. But here we are talking about the fire classification, like class A, class B, class C. This classification we are talking about, and this is entirely different. Okay. This is a very basic thing actually about the fire. So we usually don't like focus on these things, but this is for the safety purpose. Like for example, if you have seen in any mall, or if you go to any place, you will see some danger signs, like don't go there, it is a high voltage area, 1100 volts. So we usually what you can say, we usually don't follow these symbols, but these symbols are used for like protecting our lives. Actually, it doesn't have anything to do with the calculation. Even though if you are not putting those danger signs, nothing will happen, but as a safety point of view, you have to put it. This is mandatory actually. So some points are written how to prevent fire. It's very simple thing. Keep storage and working area free of trash. Don't refill powered equipment. Okay, in a space where the equipment is hot, keep flammable liquid in a tightly closed container. Some things are written here. Investigate electrical equipment. Knowledge of properties of metal will assist you in avoiding potential. There are so many ways to prevent fire. So I have just listed out some few points, because we don't have to like go in depth of in the basic of firefighting. After that, you will see that type of fire extinguisher. Now, there are basically there are so many types of fire extinguisher, but I believe these are three what you can say standard fire extinguisher which are used in our industry. Like one is the foam type of fire extinguisher, carbon dioxide type, dry chemical type. Sometimes the water type of fire extinguisher is also used. So these are the standard fire extinguishers which are used, and I think the capacity ranges will start from 2 kg. The minimum fire extinguisher will start from 2 kg and it can go up to 100 kgs also. I think 150 kgs also is available in market. Okay, like I'm talking about fire extinguisher. If you like previously we were dependent much on fire extinguishers only. So before like few years only like the system is firefighting system or the sprinklers are like in very much common. But previously we used to go with only fire extinguisher systems. But nowadays it is very much common. And here they have given one what you can say type of extinguisher, type of fire where you can use. For example, if you are going with the water type of fire extinguisher, where you can use in class A type. Class A type means in the wood, glasses, or combustible what you can say. What is that class A? Some plastics. Okay. And if you're going with the foam type of extinguisher, you can use everywhere except class D and gases. Class D is nothing but the metals. So in the metal, we cannot go with that foam. Why means because maybe because of some chemical reactions, like in the foam also we have to mix some solutions, like we have to mix some concentrates. So maybe this foam is hazardous for this metallic what you can say combustible metals, and wherever you are storing gases, you cannot go with the foam type. Dry powder can be used everywhere except the K type. K type is nothing but our kitchen, okay, normally kitchen cooking oils and the animal and vegetable fats. We cannot go like that. And CO2 type you can use everywhere except class A and gases. So this is some some things what you can say classification or some usage of fire extinguishers are given here. So this thing also we can follow. And later we will study in detail about the fire extinguishers, like what is the foam type, what is the carbon dioxide. Even NFPA has given different standard. Like if you check NFPA 11, you will see everything about the carbon dioxide type of fire extinguisher. I think NFPA 10, 11 and 12 are for fire extinguisher only. All the fire extinguisher like testing, maintenance, installation, what is the what you can say ratings, so many things are given about the fire extinguisher. So we will see later, we will see some videos also. So I will show you this one basic video, how to use the fire extinguisher. Normally this is the way how we have to use. Pull the pin, aim at the base of fire, squeeze the top handle, sweep from side to side. This is the very basic way how to use fire extinguisher. I'll just show you one video. You will understand how to use the fire extinguisher. So somewhere is given fire extinguisher. Let us see this. See here itself written here. Pull, aim, squeeze, and there is one more thing. You have to pass what you can say. Just you see this. And so this is something given. You can watch it later also. So normally what happens means in like fire extinguisher depend upon the capacity only, it will be like placed. Like 2 kg fire extinguisher is very easy to handle, but 20 kg fire extinguisher is little bit difficult. 50 kg fire extinguisher is more difficult. Sometimes the fire extinguishers are kept in trolleys also. So those things we will see later. Like if you go to any airports or any areas, ports, okay, like shipyards, so there you will find that there are like 75 kg fire extinguishers are used there also, and 150 kg fire extinguishers are also used there. So that is a different case. So this is the basic like how to use the fire extinguisher. Now we will come directly to the basics of sprinkler. Okay, so normally how the sprinkler works. So first thing is we need to understand about something about the sprinklers. Okay, now these sprinklers are designed in such a way that, okay, like all the sprinklers, whether you take any sprinkler, dry, wet, mist sprinkler, water spray sprinkler, so these are designed in such a way that it will break down. Okay, once it is used, it will break down. You cannot reuse this sprinkler. Once it is, yeah, it must be replaced. It must be replaced. Today, what we will, yeah. So today, yeah. So today we will see something about the sprinklers, like what is how the operation of sprinkler, and what is the sprinkler, what are the types of sprinkler, what NFPA is talking about sprinkler. Those things we will see. Some things are written here. We will follow this. So normally you see the definition of sprinkler says that it is a system for extinguishing fire. Sprinkler is a system which is used to extinguish fire. Water from a network of overhead pipe. Okay, just observe this term. It's very important. Water from a network of overhead pipe is released through nozzles that open automatically with the rise in temperature. This is the basic definition of sprinkler. You can like there are so many definitions are given in internet also, you can check, but the most important thing is here network of overhead pipe. Now sprinklers always run in the network of overhead pipe only. If you fail to connect this network, you can never what you can say reach 100% what you can say utilization of sprinklers, because the definition says that water should pass from the network and the overhead pipes, and it should be released through the nozzles that open automatically with the rise in temperature. Now sprinklers are of two types. Again, previously they have manual type of sprinkler, but nowadays like everyone is going for the automatic type. Why means because in manual sprinkler type you can never assume where fire has occurred, but automatic sprinklers are one which can detect, which can sense whether the temperature is rising or not, whether the fire has occurred or not. So we are going with the automatic type only. Everywhere you will find the automatic sprinklers only. Basically this was developed by some like person Henry Parmalee. It was developed in 1874. Why he developments to protect his piano factory, but later it has become the patent in the world, and they have utilized this sprinkler system for all the industries, like all the big industries there they have used. Now types of sprinkler system, like as I told you, there are four types of sprinkler system: wet sprinkler, dry sprinkler, deluge sprinkler, pre-action. So there are another types also, like mist and foam system, but I have written only four system: wet, dry, deluge, and pre-action. Now I will explain you each and every system. Okay, just try to understand each and every system. What does, how the different system is different, how individual system is different from each and every system. First, we will talk about the wet sprinkler system. Okay, before going in depth of the sprinkler system, I will show you some video. How does the sprinkler system works? Okay, just I will show you one video. Maybe most of the people know about this, but still just watch it. Only 2 minutes video is there. Just
Super.
So just something about the fire sprinkler system. Now, just try to understand one thing, that all the sprinkler function will be same, but system will be different. Okay, like the wet sprinkler system will work in different manner. The dry sprinkler system will work in a different manner. Deluge system will work in a different manner. So this thing we are going to just we will see some basics about what these systems are. Then we will learn in detail about this system when we go for the calculations. So some important points are written about the wet sprinkler system. The meaning of wet sprinkler system is that water is present in branch lines and at the sprinkler head all the time. For example, just consider that this is my line and it is going. For example, all the sprinklers are connected here. So these are the sprinklers which are connected, and wherever it has to go, it is going. So the definition of wet sprinkler says that in the wet sprinkler, this entire line, okay, this entire line is always filled with water, and this line is also filled with water. So what is the reason why the water is filled here? Can anyone tell me? What is the reason why the water should be filled here?
Because the system should be pressurized. Once the liquid inside the bulb bursts upon certain temperature, it will release the water automatically.
Yeah, that is also a correct answer. But why this system is like pre-charged with water means, because when fire occurs, okay, normally when fire occurs, what happens, we don't have enough time. Okay, we don't have what you can say, even though if you are calling any fire department agencies, they cannot instantly. Obviously, they cannot act instantly, even though if fire agency is just what you can say beside the building, they cannot act instantly. So to safeguard our property, like to safeguard the people's life, because the first thing is the people's life, second thing is the property. So that's why what they will do, they have made this wet system as very common, like every common areas like libraries, colleges, or you can say what you can say the food court areas or any mall, shopping mall areas. So these are the very common areas where the frequency of people is more. So they have made it mandatory to go with the wet sprinkler system. And simply what they are doing means they have just charged with water and they are waiting for any fire to occur. Suppose if fire is occurring at this region, so what happens? Instantly this system will activate and this fire sprinkler will activate and it will release the water. Suppose if fire is very huge.
What is the operational pressure at the sprinkler, sir?
Yeah, we are coming to that. We will come to that also. Just first I am showing you the very basic things about this firefighting system, because we will come slowly, one by one we will come. So this is the wet sprinkler. So always what you can say, always the line is charged with water. The same point I have written here. Water is present in branch line at all the sprinkler head all the times. Wet system cannot be used in freeze areas. Obviously, if you are using in any colder areas, so the water will become ice. So water cannot be hold to that temperature. So that's why we cannot go with the wet sprinkler system in the freezing areas. Water pressure must be maintained at all the times. The meaning of that is that suppose if fire occurs in this region, so the water pressure should be maintained. Because of water pressure, my system should not get filled. This is what it is. So how to maintain this water pressure? So we have to do regular and frequent maintenance and testing. O&M we have to always do. Okay, like maintenance and testing of the system will be done frequently, like every 6 months or every 1 year or every 3 months, depend upon the facility or depend upon the client. So then only we are going to maintain the water pressure. Less maintenance. Why less maintenance means? Because we don't have to open any what you can say device and all until and unless it is used. So just we need to keep it ready, the system, so the maintenance will be less. In the same way, if you talk about the dry sprinkler system, the main functioning of dry sprinkler system is that the wet sprinkler systems cannot be used in the freezing areas, cold areas. Dry sprinkler system are made only to use in the freezing areas or in the colder areas. So this is the difference between wet and dry. So what happens in dry and wet system means, just what they will do, they will just cut off the water supply at one point. What they will do, they will cut off the water supply, and here what they will do, they will keep one air compressor. Why air compressor? Because of this air compressor, the air will be filled in the line. Okay. Instead of water, air will be filled. Now, obviously, air will not become cool in the cool areas, like in the colder areas, because air is neither solid, neither liquid. Okay, air is just air. So they will be keeping the air compressor. So this air compressor will be maintaining some temperature. Suppose if any fire occurs in this region, what happens? There will be one valve kept here. Okay, so the moment fire occurs, this valve will be like open and the water starts flowing here. So this is the difference between wet and dry sprinkler system. Only difference is that one air compressor is kept, which will hold water to enter into the system because of the freezing area or because of the colder area. Because in colder areas, what happens? If water is introduced into the system, then there may be chances of freezing, and because of freezing you have to take out that particular pipe section. Because what happens, if the freezing occurs inside the pipe, there may be chances of cavitation or anything can happen. Gas will build inside, and you may not get proper pressure when the fire occurs. So that's why you have to keep the air compressor. Here also it will say the same thing, requires air pressure instead of water in the branch lines. Air pressure holds the water to introduce into the system unless the air pressure is lost. How the air pressure will lose? If any fire occurs, suppose if any fire occurs, what happens? So you will get the, we will get the signal. Okay. So because of this fire occurring event, this compressor, this valve will open. And if the valve is open, obviously the pressure will go down. And when this pressure goes down, water pressure rises up and the water starts moving into the system, and it will go here and it will extinguish the fire. This is the very basic thing what I have told you. Used in the freezing area, and air compressor keeps a constant pressure in the system. Just understand how the steam system works. Steam engine or turbines, if you go to any turbine company, you will see that one air compressor will be kept there to introduce the air to the system. So like that, here also what they will do, they will just use one air compressor, which the main function of the air compressor is to introduce air continuously to the system. Why air compressor is kept means, there are so many factors, maybe cavitation, maybe loss of pressure in the pipe, or anything can happen. That's why we have to keep the air compressor. When a fire releases sprinkler head, the air is released from the piping and stop holding the wall that was holding the water back, and water is released. High maintenance cost due to corrosion in pipe with only air. So as I told you, if you are keeping air compressor, the maintenance cost will be high, because you have to check each and every time, you have to check whether the pipe is corroded or not. So that is the main thing what we have to check in the dry system. Next, you will see the deluge system. Now, what is the difference between deluge and wet sprinkler system? Any idea? Can anyone tell me what is the difference between deluge and wet sprinkler system?
Sorry, Mr. Atif, the dry sprinkler have the same liquids, same as the wet sprinkler. I mean, the yellow, the green, and this temperature relevant, 57 degrees, for example, 68, 93 for transformer outside.
Yeah, that glass bulb will be different. Glass bulb color will be different. For different
from the dry from the wet, you right?
Dry sprinklers are different, wet sprinklers are different. You need to ask to the manufacturer. I want dry sprinkler, I want wet sprinkler. Manufacturer will guide you which is dry sprinkler, which is wet sprinkler. We cannot understand by just seeing the sprinkler heads whether it is a dry or wet. So specifically we have to ask to the manufacturer, because all sprinkler looks same only. You cannot identify which is mist sprinkler, which is water spray sprinkler, which is foam sprinkler. So manufacturer can only tell us. Now, any idea what is the difference between wet and deluge sprinkler or system? If I talk about wet and deluge system, what is the difference? Can anyone tell? Any idea? Suppose this is one room and this is the sprinklers attached to it. Now, what will be the difference between wet and deluge system? See, normally when wet system, like whenever you are installing the wet system, what happens? If fire occurs in this region, only this sprinkler will get activated. Okay. But in deluge system, suppose if fire occurring at this place, all the sprinklers will get activated. All the 5 sprinkler heads will burst on. This is the deluge system. In wet system, only one sprinkler or only that particular sprinkler where the fire is high, that sprinkler will burst off. But in deluge system, all the sprinkler heads are burst off. Can you tell me what is the reason why it is so? Why we are wasting every sprinkler? Because only fire has occurred in this region, but we are utilizing all the sprinklers.
Because like the transformer, water supply system we need for oil type transformer, we use deluge. The transformer body
yes.
need all the sprinklers to work.
Or you can simply say that because it is designed for the special fire risk areas only. Special fire risk areas means it can be anything like transformer or any hazardous gases, hazardous liquid. If it is just if it is just reacting with a very minute amount of oxygen, it can blow out the building. I will just show you one video also about the deluge system also. Yeah, see, this is this
also, one. See? Also chemical stores. Chemical stores need.
Yeah, this video is
also need this water blade foam.
Just see one video about the deluge system also. How this deluge. Just say only at this place fire occurred, but all the sprinklers will get activated. Why means because of the property of deluge system. It is installed in a very high risk area only. And I think, okay, this much only it will show. So deluge system, the main difference between wet sprinkler and deluge sprinkler system is that all the sprinkler heads are what you can say are released whenever there is a fire occur. Deluge valves are used in special cases areas. Sprinkler heads are open at all the times. Open at all the time means whenever the water is flowing, the water has to pass through all the sprinkler heads. Now deluge systems are used in very special areas like aircraft hangars or any oil transformer areas or any storage tank where there is a chance of fire, where there is a high chance of fire. And there are so many things. Deluge valve opens during the smoke or heat detection. Okay. Now there is one pre-action system. Pre-action system is also same as deluge. Means in pre-action system also all the what you can say sprinkler heads are open only. Now pre-action systems are also used in a special areas only. The only difference in pre-action and deluge system is that here the water is held back by an electronically operated valve, just like dry system. Like in the dry system, we have one air compressor cap. Here one electrically or electronically operated valve will be like holding the water to introduce into the system. Once that valve is open, the water will go into the system and all the sprinkler heads will get activated. Two things here. First, the detection system must identify that there is a problem with smoke or flame. Water is then released in the pipe. The sprinkler head must be activated and released to put water on fire. I will show you one small video on pre-action system also, which is given here. So you will understand how this system works. Where is the Pre-action. This is the pre-action system.
Is this the
Okay. Seems different. Okay. So this is like, just try to understand what is the wet sprinkler system, what is the dry sprinkler deluge pre-action. Okay, I've just shown you the overview of the system. But for every system, what is required? For every system, the hydraulic calculation is required. Okay, because without hydraulic calculations, we cannot proceed. Okay, and in hydraulic calculation, what is mostly requirements? Mostly there are two things required. What is the flow? What is the pressure? So that's why, like as I told you, like NFPA has given everything, like how much flow we have to keep, what is the pressure we have to maintain. Each and everything is given in NFPA. Just we need to put it organized in one, like in a sequential way, and we need to do the calculation. Okay. And after that, you will see that the types of sprinkler head, there are so many types of sprinkler head, like pendant, upright, sidewall, spatial coverage. The meaning of pendant sprinkler head is that the pendant is like the deflector will be in the downward direction. Okay. This is suppose the deflector of the sprinkler. In the pendant sprinkler, what happens? The water will fall like this. Okay. You can just say like shower, like how the water is falling from the shower. So in that way, the water will flow. And if you talk about the upright sprinkler, in the upright sprinkler, the water will fall like this. Okay, like a fountain of water. So this is the difference between pendant and upright sprinkler. And also you can say one more difference, that wherever you are using false ceiling, you can go with the pendant sprinkler system, because the sprinkler will be concealed in the false ceiling, and only this deflector will be visible to our eye.
It will be the concealed type. False ceiling, yes. Concealed type.
Yeah. And upright sprinklers are used where there is no false ceiling. Like for example, in the basement areas, you can go with the upright sprinkler because there is no false ceiling. But in the
where we use the pendant sprinkler, where we use it other than the false ceiling, that's the
which sprinkler? Which sprinkler?
The pendant.
Pendant false ceiling areas, all rooms and waiting areas, everywhere you can use this pendant sprinkler except basement areas. Except basement areas, you can go with the pendant sprinkler, because you will be like wherever you are placing the false ceiling, you can go with pendant sprinkler, and wherever you are not going with the false ceiling, you can go with upright or pendant. The cost is same only. Okay, nothing.
Yeah. Also, I do believe that upright sprinklers could be used between the false ceiling and the soft slab if it exceeds 80 centimeters as well.
Yes, if you are installing, yeah, I was coming to that point also. If you are, suppose if you have the false ceiling, in between false ceiling, if you want to use anything, you can go with upright sprinkler, like to protection of, for the protection of services. Okay, like protection of what you can say MEP services, like cables or anything, HVAC duct cables or any communication cables. So there you can go with inside the false ceiling, you can go with the upright sprinkler. But the most common is your basement areas, car parking. You can go to the basement or car parking, the upright sprinkler system. There is one more sprinkler system, which is sidewall sprinkler system.
That's inside the rooms of the hotels.
Yes,
and
rooms,
the staircases.
Rooms, corridors, staircase. It's up to the consumer wherever they want, room, corridor, or staircase. Sometimes what happens, the building owner or the people, they don't like water should fall on their head. So it's better to go with the sidewall system, so that water will, the effect of water will be less here as compared to pendant, because the pendant directly it will fall on our heads, but the sidewall sprinklers, it will not fall directly on our heads. And there is one
also both inside the hotel rooms inside hotels it will use
yes exactly
not pendant. Okay.
Yeah, and there are some color codes are given. So I think some color codes are given in NFPA also. NFPA has given some color code like red bulb color, green bulb, blue bulb, like that. There are some color codes. I think here you will see there is one more book actually. Here I have written about the color code. See, this is the color coding of sprinkler system. So this particular, what you are seeing, I have taken from the NFP only. So here you can see the temperature ratings are given in degree Fahrenheit. It can start from 135 degree Fahrenheit up to 575 degree Fahrenheit. And these are the color ranges. The glass color ranges are given like black, white, blue, red, green, orange. And this is the temperature classification. Now, again, this temperature classification doesn't have to do anything with our calculation. This might be the temperature classification given for the manufacturer side. Like manufacturer will decide which is the ordinary temperature, which is the high temperature based on the temperature rating. Here you will see the complete classification of sprinkler head: upright pendants, side extended, dry upright, dry pendant, quick early separation, fast response sprinkler, recess, flush, concealed, residential, on off. So many types of sprinkler system, which we will see later when we go for our NFPA 13 topic. That time we will see some different types of sprinkler systems. Here one important thing is written: how does the sprinkler work? Just now in video we have seen, but still some points are written here. The sprinkler system inside building is actually a network pipe that are sized from either pipe schedule or hydraulic calculation. These are the two methods what we can follow for doing the calculation, sprinkler calculation. But I don't know who is following pipe schedule. We will follow hydraulic calculation because we are doing the hydraulic calculation. So mostly we will follow the hydraulic calculation. Now, what is the difference between pipe schedule and hydraulic calculation method? That I will
for pipe schedule, schedule 40 and schedule 80 pipes.
I will tell you in the NFPA 13. Actually, this is the difference lies in the pressure. Actually, pressure and flow. The different pressure and flow for pipe schedule, different pressure and flow for the hydraulic calculation. The system is installed overhead and sprinklers are attached to the pipe in a systematic pattern. The valve controlling each system riser is located in the system riser supply piping. Some points are written: heat from a fire triggers the sprinkler system, causing one or more heads to open and discharge water only over the fire area, except in case of deluge system with permanently open heads. An automatic sprinkler system should be connected to an automatic water supply, such as municipal water main or fire pump. The water supply must have the required pressure and capacity. Okay, some points are written. And here one more important point is written, that you have to use one drain system also. all sprinkler system must be installed so that the system may be drained if necessary. Suppose you want to go for the maintenance purpose. For maintenance purpose, what we have to do, we have to drain out the water. So that's why all the sprinkler systems are designed in such a way that it should be connected to our drain system. Now this drain, whatever the drain system you are designing, you can take wherever you want. Either you can use that for your like plumbing usage, or if you want to drain out the water into the like outside the building, you can use. That is a different scenario, but the drain wall should be connected. Then after that, some things are written about the sprinkler head. What is the meaning of sprinkler head? It is a thermosensitive device that is automatically activated when an area reaches a predetermined temperature. Once this temperature is met, the sprinkler head releases a stream of water and distribute over area. Water reaches the sprinkler head through a network of overhead pipe at regular intervals. If you check closely the sprinkler, it will look like something like this. I will show you sprinkler heads. Okay, firefighting, you will understand. See, this is a deflector actually. What you are seeing this like this is a deflector, this is the glass, and this is the complete configuration. This is how the installation of a sprinkler will be done here. Okay, this is how the sprinkler looks like. So here also I tried to show you the same thing. This is the deflector position. This is, and there are two types of system actually. One is the fusible link and one is the glass bulb or frangible bulb. So in the frangible bulb, what will happen means the bulb will be given here. See, this is the bulb. And somewhere you will see the fusible link also. See, this is the fusible link. So I don't think like fusible link who is using, but in India, we usually see that glass bulbs are used only. So you can go with any one. It's up to like it's normally there are two types of systems are there. One is the fusible link and one is the glass bulb. Here some points are written about the sprinkler head. Under normal condition, water discharge from an automatic sprinkler head is restrained by a cap held tightly against the cap. There are two types of restraining elements, fusible link and frangible bulb. And temperature rating of fusible link and frangible sprinklers are given here. This is the temperature rating, color code for fusible link. This is the color code for glass bulb. So this is the most common sprinkler. Why means because in most of the places, commercial building, residential building, you will find red color sprinkler only, the red glass bulb color. Why means because this red color glass bulb sprinkler temperature range is 135 to 170 degree Fahrenheit. Usually it is 68 degrees Celsius. If you convert it into degrees Celsius, it will be 68 degrees Celsius. This is the very common sprinkler.
But is this the K factor? Is this the K factor?
No, this is the temperature rating. K factor is 5.65.
5.7, something like that.
Yeah, 5.65. So K factor is also a different thing. Like each and every sprinkler will have different. This is the range given in NFPA also. The same thing I have copied from NFPA. What is the meaning of deflector? Something is written about the deflector. Deflector is attached to the sprinkler frame. When a water stream is directed against the deflector, it is converted into a spray of certain shape designed to protect design area. The water discharge rate from sprinkler head follows hydraulic law. It depends upon the orifice size and water pressure. The standard sprinkler head has ½ inch of diameter orifice. Now, you will see somewhere here, there will be orifice also. So that orifice is nothing but this is the standard ½ inch in diameter. Okay. So this is what it is telling. And something is written about now all the sprinkler system are mandated to have devices that will sound an alarm. Okay. Some things are written here about. So you can just go through that. So this is the operation of sprinklers are given here. And then again, I will come back to here. Here you will see written some note point here. Yeah.
Mr. Atif, you are sending us only the videos. There are many data sheets in PDF I can see. Are you going to send it to us as well on our email only videos?
Yeah, I will share. I will share.
There should be PDFs. These are PDFs. Videos is not enough because you are moving very fast the slices. We need the PDF of these papers documents.
This is the very basic things. I'm just like you can study when I share you this material. You can go through this also. Okay. And here you see some point I have written here. So this point also I have taken from NFPA 13 only. The maximum pressure, okay, for any sprinkler system is 175 psi. This is the maximum pressure for any sprinkler based building. So this point is given in NFPA 13. So when we open the NFPA 13, I will show you where it is written. And a working pressure is also given 150 psi. And there is a test pressure is also given. The test pressure should be 200 psi or 14 bar, and the length of the test must be 2 hours. Okay. So this particular point why I have written here means sometimes you will forget. Okay, whenever you are doing any calculations or you are not getting any pressure, so you can come back here and check this. And here I have also written the minimum operating pressure of any sprinkler, which is 7 psi or 0.5 bar residual pressure. Now, what is residual pressure? What is the meaning of this minimum operating pressure? This everything we will understand when we go to the NFPA 13. Just I have written here so that you will have a quick review whenever you are going for your, like whenever you want to do any brush up, you can review these things. Standard sprinkler head has a 1/2 inch of diameter orifice. Now here I have written something about the remark for sprinkler design. This is the most important point, which I will not explain right now, because when we go to NFPA 13, these are the points which we are going to like understand from NFPA 13. But I have just written here why means because I know that every time you will not open this NFPA 13 book and you will check for what is the maximum spacing, what is the minimum spacing. That's why I have just written here for easy understanding purpose. So there are normally, whenever we are talking about the sprinkler, we have to calculate or we should know some things. Like whenever I am placing one sprinkler in any building, so I should know certain things, like what is the area it will cover. First thing, I should know what is the area it will cover. Second thing, what is the distance? How much distance? Okay, the distance between two sprinkler I should know. What is the distance between two sprinkler, and what is the distance between wall or distance from the wall we should know. So these are the certain things which we should know. So that's why I have written here the same thing. What is the maximum area? What is the maximum spacing between two sprinkler? What is the maximum distance from wall? Minimum distance from wall, and minimum distance between two sprinkler. Everything is written here. I will show you when we see the NFPA 13 how we arrived at these points, because everything is written clearly in NFPA 13. Like that, I have written for some sprinklers here. So these things we will just avoid for now and we will check later. Types of hazards. There are 3 types of hazards. The classification of building is according to the type of hazard. Now, the classification of building is entirely different in NFPA, and the classification of building is entirely different in NBC. So whoever is doing the Indian calculation, they don't get confused, because the classifications are entirely different here. The light hazard, ordinary hazard, extra hazard is the classification defined by NFPA. It is an international definition. And here I have written the names of the building also. Again, I will tell you, these points I have taken from NFPA 13 only. Okay. And I have written these points here. What is the types of building? Light hazard: churches, clubs, education, hospital, institutional, libraries, except large stack room. The meaning of this point is that small libraries, not the big libraries. Museums, nursing homes, offices including data processing. If you have any data processing offices, server rooms inside the office, those offices are also considered in the light hazard. Attics, any attic area. Residential, restaurant seating area, theaters and auditorium, unused attics. So these are the buildings which will come in the light hazard. Ordinary hazard: automobile parking, bakeries, beverage manufacturing, canneries, dairy product, electronic, restaurant serving areas. Now restaurant serving area is different and restaurant sitting area is different. Both are entirely different. One is light hazard, one is ordinary hazard. In the same way, ordinary hazard group 2, extra hazard group 1, extra hazard group 2. So many things are given here. And area limitation. Again, this point I also have taken from NFPA 13. This is the maximum floor area which can be protected by any sprinkler which is given. Okay. For light hazard, for ordinary hazard, high piled storage, extra hazard. So these things anyhow we are going to study in our when we are going further with NFPA 13. But still I have written something. And this is the K factor table. Okay. Again, this K factor table also I have copied from the NFP only. So our standard K factor table is standard K is this value 5.3 to 5.8. The orifice size is half inches, and the maximum K factor you can go we can go any K factor. It's up to like anything we can go. Some example is given, small example how to find the K factor. This is the formula to find the K factor. Again, this formula is given in NFPA 13 only, NFPA 13, 14. You just know what is the Q value. If you know K value, you can easily find the pressure value. If you know what is the pressure value, what is the K value, you can easily find the Q value. One example, one here. So, and some one also I have written here the drain pipe sizing. What is the drain pipe size we have to consider for the sprinkler system? Like if the pipe size is 2 inches, we should go with the 3 by 4 inches. If the pipe size ranges in between 2.5 to 3.5 inches, we have to go for 1 by 4 or 32 mm. And if the pipe size is more than 4 inches, the maximum drain pipe we can go with 50 mm. This table is also given in NFPA 13, which I have written here. Okay.
Which page in NFPA? Which section?
That we need to check in NFPA 13. When we open NFPA 13, I will tell you from where I have taken, because these are some important points which I have written here, so that you don't have to copy always come. And also I will share you one Excel. Actually, I find this Excel very good actually. Where is that Excel sheet? This Excel is I find this Excel very good. This one of the one of my friend has shared this sheet. So in this particular Excel, everything like NFP 13 and 14 is written here only. I will share you this later, because if I share you now, you will not understand. So maybe 1 or 2 days, I will share you. Everything is written here.
I'll share you. You share it now as well with the video? Structure? Can you share it?
I will share in the mail ID. So I try to explain something about the sprinkler system, very basic things. In the same way, there is one hydrant system also. I think just we will go quickly. I think nothing is given about the hydrant system here, because hydrant system, we will anyhow, when we will see NFPA 14, we will understand this hydrant system, because NFPA 14 is not a very big topic. It's a very small topic. Only what is the difference between sprinkler and hydrant system is that the pressure. The pressure is the most, what you can say, and the flow. So we need to understand what is the pressure and flow for sprinkler system, what is the pressure and flow for hydrant system. The maximum.
Hydrant 2 types, indoor and outdoor, right? Indoor,
no. Not like that. Not like that. It is not like that. It is not like that. It will be defined in terms of classes actually, class 1, class 2, class 3 system. So that we will take tomorrow. So tomorrow we will directly go into NFPA 13. So first we will try to understand NFPA 13. Now I will just give you one quick review about the NFPA 13. In NFPA 13, they try to explain about the sprinklers in detail. Okay. They have taken few sprinkler systems like pendant, upright, standard, CMSA, ESFR sprinkler, and they try to explain about the sprinkler system. One section is given about the storage type of building. Okay. Now this storage type of building is a very big topic. So this storage type of building we will take separately. Okay, because there are so many things given. There are so many types of storage types of building are given, like rubber industries, glass industries, plastic industries, commodities. it's a very big sector given, or it's a very big section about the storage is given. And one section is given about the hydraulic calculation procedure. So first they have given about some types of sprinkler, and they have given a section about the storage, and they have given about the hydraulic calculation procedure. So in our tomorrow's class, we will try to cover these two sections first, because storage type of building is very confusing. I will tell you, it's a very confusing topic, and it requires at least 2 hours. If we want to crack down this storage type of building in NFPA 13, we require at least 2 hours. So that's why what I will suggest that we will take this topic separately later when we complete our hydraulic calculations. Okay. First, we will focus on these two topics. The procedure. Now remember that first we will understand the procedure, then we will go for the calculation. This is the NFPA 13. In the same way, we will follow for the NFPA 14 also. And I will also take one class on NBC. Okay. NBC is for the Indian calculation. If anyone doesn't want to attend that class, it's not an issue, but it will be additional knowledge. So one day we will keep for only NBC requirements. So that why I'm taking first NFPA means because this is the international standard. First we will try to understand NFPA. Later we will see NBC because both the standards are entirely different. In NBC, they have given only about the local regulations, and in NFPA, they have given about the standard international regulations. So with this, we will stop here only, and I will share you all the videos and all relevant data. And obviously, I have the mail IDs. I will just in the mail IDs.
Mr. Atif, there are many sheets we have seen about the cave factor and this green, yellow, red, the temperatures. They are in documents PDF. We need to share it with us. We need to memorize it tonight. I want to memorize it. I want to study.
So you don't.
Other than the video is not enough. The video is not enough to share with us.
That's why I told you, like, I will share you all the relevant data, like whatever we have seen. Through mail, I will share you. Okay. Like through mail, I will share. And you don't need to memorize the things. You cannot memorize the thing. Why to memorize it? Whenever you require anything, just come back to that PDF or come back to that particular.
Basically, we need to know, for example, 0.5 bar is the operating pressure of the sprinkler, for example.
Yes. You need to memorize, like you need to remember some things like the pressure flow. So, and in one day, you.
For example, indoor hydrant was read 4.5 bar operating pressure. Outdoor hydrant 6.7, I don't believe. These things we need to keep in our mind. We need to memorize.
See, that's why I will share you this sheet also. Suppose if you require for any interview purpose or any quick revision, this is the best sheet. Okay, like here it has defined system type, hazard classification, sprinkler coverage. I will share this sheet also. You can.
Sir, we need to know this
pipe sizing and everything is given. Yeah.
Okay. One more thing. Are we going through the piping system? For example, the galvanized pipe, carbon steel. There is schedule 40, schedule 80. And there is also HDP pipe underground.
See,
there are SDR 12. I do believe the new 8 SDR 9 they are using. Are we going for the pipe?
I will tell you one thing. We will do Elite software. Now, Elite software is used for every system. See why Elite software is very much popular in throughout the world. You know, because Elite software has the options for selecting any pipe. You can select any pipe. You can put any pressure and it will do the calculation according to that particular. Now, as you told me that whether you require HDP pipe and all, I'll just show you one like example for that. Example means I will just show you one demonstration here. Very quick, just 1 or 2 minutes I will take. See, in Elite software, what happens if you open any project here, what will happen? There will be a one section given for pipe material. Now you can select any pipe. See, cast iron PVC schedule 40, CPVC SDR schedule 10, MR Blaze Master. So many pipes are given. So whatever the pipe you are going to select, what you can say, the calculation will be done for that particular pipe. But usually I will show you the example for this pipe, schedule 40 wet steel, because schedule 40 wet steel is nothing but your MS pipe, MS or GI pipe. So
mild steel.
Yeah. If you want to select this pipe, carbon steel, you can check the reference number for carbon steel pipe. Like carbon steel pipe, what is the reference? Let us see.
Schedule 40 and schedule 80, I think the difference in the thickness of the pipe, I do believe.
Yes. You need to check from this what is the carbon steel pipe, because I don't think they have given directly carbon steel pipe. Instead, they have given copper tube, schedule 10 wet, schedule 40 wet steel pipe. Cast iron they have given, carbon steel they have not given here. Or you can go with this one, I think so. Schedule 40 steel body, steel dry or steel black. So maybe this will be your pipe. Schedule 40 carbon steel. Dry.
This one, steel black.
8 or 9. You have to remember this reference number. Then if you select this, the calculation will be done according to that pipe only. This is the beauty of this Elite software. But still, the Elite software, what I am going to provide you is for the 1000 nodes. So normally, actually, if you talk about the original Elite software, I think in original Elite software, we can get the 5000 nodes. But this original software, you have to buy from the direct company, and it will cost, it is a very costly software, but still you will get the 1000 pipe software. So 1000 pipe means 1000 pipe is also more than enough. You can design the high-rise building with this 1000 pipe section. 5000 pipe is, maybe they have kept the original. I heard that only that there is this is also available 5000 pipe, but I never saw. I think maybe in US only premium are using this software. I don't know, but I will give you the license with license file this software, because if you understand this hydraulic calculation, okay, just understand one or two example, then you can apply in any way. Just as I have shown you here, just one thing here. In the same way, the K factor also you can select. Any K factor you can select. It's up to you. Whatever the K factor you want, the range is given. K factor range starts from 1.3 and end up to 14.5. Suppose if you want to go more than this, suppose sometimes you are going with 22.5, 27.5, you can directly write here also K factor. So this is the one thing. And remember that the Elite software is calculating only pressure and flow. Okay, only it will show you what is the pressure, what is the flow. Okay, so anyhow,
and
see,
and the loss, right? There is also pressure losses, right? It will calculate the pressure losses, right?
Pressure losses, I think pressure losses it will not calculate. It will calculate actually each and every point what is the pressure requirement. What is the pressure requirement at each and every point it will calculate. Pressure loss,
it will calculate the header, because the pressure losses are inside the header, right?
Yes. Suppose, for example, if my line is like this is my header pipe, for example. Okay, this is my header pipe. This is my header pipe, and these are my branch pipes. So it will start calculating from this point, and at each and every point it will calculate what is the pressure requirement. So you will obviously you will get to know what is the pressure here, what is the pressure here, what is the pressure here, and suppose here you have the pump, what is the pressure at the pump. Everything you will know with the help of Elite software. Even the flow, pressure and velocity, all the thing you will calculate. Flow, pressure and velocity.
Header, it will be also calculated. The head of the pump header it will be calculated.
Head, okay, yes, head also will be calculated. Head, flow, pressure, velocity, all the four things will be calculated.
The header, if the header calculation, it is the losses, right?
Sorry?
The header calculation is the losses, the pressure loss inside the pipes, elbows, whatever.
Everything of the pipe. It will calculate everything. Once you define the pipe sections, once you define the nodes, it will calculate everything. Whatever the elbows, whatever the T's, whatever the fittings you are giving, according to that fitting, it will calculate. You don't need to bother about those things.
So we can print also as well this hydraulic calculation, right? If it is asked by the civil defense or something.
This is the hydraulic calculation.
Okay,
this is the hydraulic.
Yeah.
If you are calculating this 4 point, this is called as hydraulic calculation. It's simple. If your reports are calculating flow, pressure, velocity, head, then it is called as hydraulic calculation. Now, whatever the system you select, it doesn't say allied calculation doesn't require any system. Only you need to give the pressure. What is the pressure requirement? What is the system pressure requirement? That if you give, the software will understand that, okay, you are trying to do for this pressure. Software will never understand that you are doing for mist system, foam system, or pre-action system. It will only ask whether you are going for wet system or dry system.
Do we need to get from AutoCAD the P&I diagram to get this calculation? P&I diagram or
yeah, AutoCAD drawing is compulsory, because if you do the AutoCAD drawing properly, then only you can do the allied software calculation properly. Otherwise, it will be very much difficult. But if you are a designer, you don't need to go for the AutoCAD first. You can make the rough sketch also. Initially, you can make the rough sketch, then you can do the calculation. Then you can ask any draftsman, or you can only do design, and then again you can recheck with your calculations. Like that also you can do. It is not necessary that first you have to do, because whenever you are doing allied calculation, you will be doing, you have to select 2-3 alternatives actually. Sometimes what happens, the routing, the modeling, the drafting, what you are following, it will not give you the proper calculation. Then you have to change the routing, you have to change the layout, then you have to check once again, because the files, the calculation files will be sent to the agencies. So they will be approving. If they have approved, means your design is safe. Now, in future, if any fire occurs, the designer will be safe in that manner. So like that, you have to do a couple of things. Okay, then.
Okay, sir.
Stop.
Mr. Atif, before we start the